Most organizations treat the Power Platform as a simple tool for building apps, but they are wrong. What they are actually operating is a massive distributed decision engine that makes thousands of real-time governance calls every single day. That distinction matters because this engine either enforces your intent at scale or it degrades into a state of conditional chaos. The million-dollar opportunity here is not found in building more apps, and instead the real value lies in engineering the control systems that prevent those apps from becoming entropy generators. So you need to learn to think like a value architect rather than a feature implementer, which means shifting your focus from the individual tool to the broader system. This is not an episode about software features, but rather an episode about systems thinking and architectural inevitability. By the end, you will understand why the smartest way to architect efficiency is not to construct more solutions, but to architect the governance that allows those solutions to survive contact with reality. The $2.4 trillion problem nobody names. Technical debt currently consumes 40% of IT balance sheets and eats up nearly half of all developer time across the enterprise. The global cost of poor software quality and system complexity has reached $2.4 trillion annually, and this is not a rounding error, but the literal cost of disorder. Most organizations have reached the inflection point of the S-curve where they face maximum complexity growth and maximum cost. The entire sector is approaching peak entropy, yet most CTOs do not even have a word for this phenomenon. In an IT context, entropy is not about thermodynamics, but about architectural failure. Entropy in enterprise systems manifests as three interconnected types that degrade your environment and drain your resources. Information entropy is pure uncertainty, creating chaos in decision-making when nobody can agree on what the data actually means. Structural entropy represents organizational disorder characterized by layers of teams, conflicting priorities, and fragmented processes. Finally, energy entropy is the resource waste and productive capacity lost to managing this disorder instead of delivering actual value. These three types do not operate independently because they are designed to compound and cascade. Increased structural entropy creates more information entropy, which then multiplies energy entropy until the system fails. One poorly governed environment inevitably spawns 3 more, and one orphaned app becomes 10, and a single security group exception eventually turns into 100. Your enterprise is not actually innovating faster, it is simply accumulating disorder at a higher velocity. In the Power Platform specifically, this problem manifests as massive app sprawl. 40% of enterprise low-code apps sit unused or abandoned, and this is not just a failure, but waste with a license agreement attached. Organizations with 8,000 apps often have no clear ownership model, no lifecycle management, and no way to attribute costs. What they actually have is entropy at scale. The uncomfortable truth is that your enterprise is at this inflection point because you are not governing what you have already built. Every new app created without clear ownership is not an innovation, but a liability waiting to be discovered during an audit. Entropy in IT shows up in 3 observable ways that you can track. First, state entropy occurs when data drifts and configurations change without any documentation, making the system unpredictable. Second, interaction entropy causes cascading failures to multiply, such as when one misconfigured connector breaks 3 flows that touch 3 different teams. Third, architectural entropy builds up as flags, special cases, and exceptions accumulate until a simple system becomes a puzzle. The financial leak caused by this disorder is immense. Organizations currently spend 60 to 80% of their governance time on manual reviews that should have been automated long ago. Manual permission audits, manual app inventories, and manual connector reviews are all part of an entropy tax that drains your budget. The transition from an app builder mindset to a control plane architect mindset is where the real money lives. You do not find value in building faster, but in preventing disorder and moving with architectural certainty. The smartest way to architect efficiency is to realize you do not reduce cost by building less. You reduce cost by engineering the systems that allow building to happen safely, repeatedly, and predictably. That is the control plane, the authorization compiler, and the necessary move from reactive governance to deterministic policy. Why app builders miss the one melon. The low-code narrative sold to the modern enterprise is fundamentally incomplete. Vendors marketed speed, consultants promised agility, and architects promised a new era of innovation velocity. Technically, they all delivered on those promises. Organizations are building apps faster than ever, and teams are moving with more urgency, which means the initial outcome looks exactly like the sales deck. But that narrative stops the moment the app is deployed. It fails to account for what happens after the app exists, and it certainly doesn't price the long-term cost of ownership. It doesn't quantify the governance debt or measure the architectural entropy being generated every single day. This is the exact point where app builders miss the one minimum opportunity. Apps are tactical outputs. While a finished app might solve a specific problem quickly, a tactical output is not strategic infrastructure. Strategic infrastructure is the foundation that allows 1,000 apps to coexist without creating a series of cascading failures. It is the framework that enables governance at scale without turning every new idea into a bottleneck. In architectural terms, that infrastructure is the control plane. Most consultants in this market are simply selling labor. They build apps, they train citizen developers, and they set up Power Automate flows before moving on to the next billable engagement. This model creates revenue and keeps the invoices flowing, but it leaves the enterprise with a pile of apps and no engine to manage them. The 1-9 opportunity exists in a completely different place. It exists in selling the authorization compiler, which is the policy framework that allows 10,000 apps to run simultaneously without collapsing into conditional chaos. You find the value in the observability layer that detects entropy before it becomes a major security incident. The real money is in the intellectual property, like the templates and architectural patterns, that an enterprise can reuse infinitely without buying more consultant hours. That distinction is what separates a basic app builder from a true value architect. App sprawl is not a sign of success. It is a symptom of an absent governance architecture. When an organization deploys 100 new apps and calls it innovation, they usually haven't measured the cost of managing that mess. They haven't calculated how much the breach surface has expanded, nor have they priced the audit time or forecasted the inevitable licensing drift. Consider the reality of an enterprise with 5,000 apps where 40% of them sit completely unused. That means 2,000 apps are burning through licenses and consuming environment capacity while exposing sensitive data, all without delivering a cent of value. Someone still has to own those apps, someone has to review the connectors, and someone has to validate the data access. Without a control plane to automate that work, the enterprise is just staffing a full-time operations team to manage waste. That isn't innovation, it is just entropy with a license agreement. The financial leak is easy to quantify. In a mature tenant with 8,000 apps, having 40% of them abandoned means 3,200 apps are generating zero value while consuming real capital. One enterprise recently eliminated 3,200 unused apps and recovered $400,000 annually in licensing alone. They didn't do this by building faster apps, they did it by auditing what existed and removing the dead weight. But here is the architectural truth that changes the game. The moment you implement an authorization compiler to translate policy intent into enforceable configuration, you shift from managing apps to enforcing intent at scale. You move away from reactive permission fixes and toward deterministic policy enforcement. This shift replaces manual reviews with automated compliance validation and turns bottlenecked approvals into scalable governance gates. That shift is where the 1M surfaces. App builders deliver solutions, but control plane architects deliver value platforms. One is tactical, while the other is strategic, and while one consumes time, the other generates multiplying returns. The transition between these two mindsets is not subtle. It requires you to reposition governance not as a constraint on innovation, but as the primary accelerator of it. The organizations that get this aren't arguing with their CISO about compliance because they've designed frameworks that make compliance automatic and invisible. That is the 1 move, and that is where the true efficiency lives. Scenario 1, app sprawl. Collapse the financial reality. This is not a hypothetical situation. This is the median state of mature Power Platform tenants as we head toward 2026. Imagine an enterprise that has deployed 8,000 low-code apps across the organization. If 40% are abandoned, you have 3,200 applications consuming resources and creating risk with no clear ownership or lifecycle management. These applications exist because someone solved a problem once, but then that person left the company and the app remained like a ghost in the system. This scenario plays out the same way across dozens of mature deployments, regardless of the specific scale. Whether it is 8,000 apps or 12,000, the percentage of unused applications stays remarkably constant while the financial leak continues to accumulate. Here is what that leak actually costs you. First, you have license sprawl, where each app consumes platform capacity that has a specific cost per user and environment. Unused apps still require these allocations, meaning the organization is no longer paying for innovation, but is instead paying for the storage of abandoned work. Second, there is the support overhead. Even if you aren't actively maintaining these apps, you are supporting them passively. When a maker leaves and an application becomes orphaned, or a connector updates and breaks a flow, support has to investigate. They have to hunt down owners and determine if the app should be decommissioned, which is a pure labor cost and a direct tax on your entropy. Third, you have to deal with security surface expansion. An unused app is never an inert app because it still possesses connectors, data access, and permissions. A breach doesn't care if an application is popular, it simply exploits whatever it can reach. 40% of your portfolio represents 40% of your potential attack surface and data exposure risk. Fourth, consider the compliance audits on these dead applications. When a regulator demands proof of data governance, the enterprise has to audit every single flow and connector. If nearly half of your apps are abandoned, your audit cost and investigation timeline are both 40% higher than they ever needed to be. This adds up faster than most architects realize. One mature enterprise managed to eliminate 3,200 unused applications through a disciplined governance effort. The result was a financial recovery of $400,000 every year in licensing alone. This wasn't a revenue gain, but a simple elimination of waste where the organization stopped paying for things that didn't exist. The architectural insight here is that this cleanup didn't happen by accident. It happened because someone implemented a governance framework that provided visibility into ownership, usage, and compliance status. That framework is the control plane, and it represents the authorization compiler in action. Without that framework, the enterprise would have kept burning $400,000 every year on nothing. With it, they recovered that capital and redirected it toward actual innovation. But the recovery was only the beginning of the value. The moment an organization realizes 40% of their portfolio is waste, the questions they ask begin to change. They stop asking how to build more apps and start asking how to govern what they already have. They move away from accelerating innovation and toward eliminating entropy. That shift in questioning is purely architectural. It moves the conversation from tactics to strategy and from features to systems. The financial proof is undeniable, as the organization recovered $400,000 from waste while also reducing annual governance costs by another $200,000. With fewer applications to audit and fewer permissions to review, the efficiency began to multiply. The real value of control plane architecture isn't just what it prevents from breaking. It is the entropy it refuses to generate in the first place. The financial recovery from that discipline compounds forever, because the moment you stop building chaos, you finally have the capacity to build with intent. That is the financial reality of app sprawl collapse, and that is exactly what control plane governance is designed to fix. Scenario 2. RBAC entropy and the over-permissioning trap. App sprawl was the headache of the last decade, but the problem we face today is permissions. This issue is far more dangerous because it remains completely invisible until it manifests as a massive data breach. Most enterprises are currently sitting on layers of security groups that have accumulated over years or even decades. When a new user joins a team, they get added to a group, but when that user moves to a different department, nobody ever thinks to remove them. If that employee eventually leaves the company, their group memberships often stay exactly as they were. When you multiply that across thousands of employees and dozens of reorganizations, you aren't looking at a permission model anymore. You are looking at a thick sediment of historical decisions that no one has bothered to revisit. This is not a simple case of misconfiguration. In reality, it is a form of structural entropy within your entire authorization model. Admin privilege drift is the inevitable consequence of an absent architecture rather than a one-time mistake. It is the predictable result of having no lifecycle management for entitlements, such as when someone is granted admin rights to solve a crisis, and those rights remain long after the urgency has faded. We see this when contractors get permanent permissions for temporary projects or when a one-off business exception slowly hardens into permanent company policy. None of these are individual failures, but when you step back and look at the big picture, they represent a total architectural collapse. There is an architectural truth that separates high-level control plane thinking from reactive firefighting governance. Every except clause you add to a conditional access policy converts a deterministic security model into a probabilistic one. A deterministic model is compiled once and enforced everywhere with a certain outcome, while a probabilistic model must be interpreted every single time, making it prone to drift and unpredictability. The second you add an exception for a specific department on a specific day, you have moved away from enforcement and into the realm of interpretation. You have introduced a hidden decision point that will never be audited, and in doing so, you have created a perfect vector for misconfiguration. You are delegating critical decisions that you never actually revisited. Conditional access policies tend to accumulate these exceptions until they become a nightmare to manage. A policy might start with a simple requirement for multi-factor authentication, but then it gets an exception for contractors and then another exception for those contractors if they connect from a specific IP range. Eventually, you add another layer for legacy applications. By the time you have 5 or 6 of these layers, you haven't actually written a security policy. What you have written is conditional chaos. The financial drain caused by this entropy is massive, starting with the expansion of your breach surface. The more over-permissioned your environment becomes, the larger your attack surface grows, which means a compromised credential in finance doesn't just put financial data at risk. It gives an attacker a path into HR, legal, and every other system that user touched during their 10-year career. A breach does not care if a permission was intentional or accidental because it simply exploits whatever it can reach. The second cost is the multiplication of audit time. When a regulator demands proof of your entitlement governance, you are forced to manually review every single user, every group, and every past access decision. An organization buried in over-permissioned users will spend 60 to 80% of its governance time on manual reviews that should have been automated. This includes manual validation of group memberships and the remediation of violations, all of which is just a labor-intensive entropy tax on your business. Third, you deal with much slower provisioning cycles. When access decisions require manual intervention, every approval becomes a bottleneck that slows down your entire operation. New hires sit idle because they can't get into the systems they need, and teams find they cannot scale because their onboarding process is gated by limited governance capacity. The organization loses its ability to move quickly because the control plane was never automated. Finally, there are the compliance violations. Over-permissioned environments simply cannot pass modern audits, and regulators will not accept "we aren't sure" as an answer to questions about who has access to what. Every user with too much power is a violation, every undocumented exception is a failure of control, and every manual workaround serves as evidence that your governance is missing. The control plane solution is to treat authorization as compiled policy instead of manual configuration. You must define your policies once at the highest level, compile them into deterministic enforcement code, and then deploy that code to every decision point in the network. Audit the outcomes and never allow for interpretation or exceptions. You should never delegate a decision that you cannot trace back to its source. The moment you stop managing access and start enforcing policy, the entropy begins to collapse. Your provisioning speeds up, your audits become simple, and compliance starts to happen automatically while your breach surface shrinks. These scenarios of app sprawl and RBAC entropy are well-known historical problems that are expensive but solvable. However, a third scenario is unfolding right now, and it is far more urgent. Scenario 3. AI Agent Governance Chaos, the urgent present. App sprawl is a problem of the past and RBAC entropy is the struggle of the present, but AI agent governance chaos is the crisis currently unfolding inside your tenant. Copilot Studio agents are popping up across enterprises without any enforcement of data boundaries or cost controls. They are being built without prompt injection, risk mitigation, or any kind of governance framework. And this is not a theoretical risk we need to prepare for in the future. This is happening in your organization today, where someone likely built an agent last week that you know nothing about. That agent has access to your SharePoint files, it has connectors to your ERP system, and it can execute complex flows without any approval gate or termination switch. It is autonomous, it is powerful, and it is completely unsupervised. The sheer scale of this shift amplifies the risk. Copilot Studio has already reached 230,000 organizations, and 90% of the Fortune 500 are already using it. Experts project there will be over 1 billion AI agents by 2028. In just 4 years, the number of agents in your environment will dwarf the number of traditional applications. Despite this explosion, most enterprises still have no framework in place to govern these agents at all. There is a governance gap here that should be terrifying to every CIO. 63% of organizations currently cannot enforce purpose limitations on their AI agents, and 60% lack the ability to shut them down quickly if something goes wrong. Over half of these organizations cannot even isolate their agents from sensitive networks. This isn't a lack of software features, but a total lack of architecture. This is structural entropy multiplied by the speed of autonomy. Think about what this means for your daily operations. An AI agent is granted permission to access customer data to solve one specific business problem, but that agent is now an autonomous actor. It functions without human intervention and makes its own decisions about which data to pull and what to do with it. If that agent has a connector that sends data to an external API and it decides to use it, there is no system in place to stop it. No one is there to validate the decision or confirm that the action actually matches the original intent. Most organizations have no mechanism to say that an agent can read customer data but is forbidden from sending it externally. They have no way to enforce those boundaries, so they simply grant the permissions and hope for the best. Even worse is the fact that 60% of companies cannot terminate these agents. If an agent starts hallucinating, escalating its own access, or attempting to exfiltrate data, the organization has no way to stop it instantly. They cannot easily revoke its credentials or suspend its execution, so they have to wait for a human to step in and find the off switch. That delay is your risk window, and that is exactly where major security incidents live. This isn't happening in some distant company, but right inside your own tenant. An agent exists right now that you didn't authorize, carrying permissions you didn't explicitly grant, and making decisions you never signed off on. The only architectural solution that actually scales is the zoned governance model. Zone 1 is for personal productivity and experimentation. This zone has low governance overhead and no access to production data, allowing a business user to build an agent for drafting emails without needing a formal approval. Because the risk is low, the agent stays contained and doesn't require constant oversight. Zone 2 is for collaboration and team-level controls. This zone requires pre-approved connectors, audit logging, and strict data classification. If a team builds an agent to summarize internal documents, they must pass through governance gates and permission validation to ensure the agent stays within its bounded scope. Zone 3 is enterprise managed for production deployment. This requires full monitoring, compliance enforcement, and human oversight for every action. If an agent is handling customer interactions, it needs maximum governance, including execution monitoring and the ability to terminate it instantly. This model prevents the all-or-nothing governance trap that usually kills innovation. Zone 1 allows for fast experimentation without the weight of bureaucracy, while Zone 3 provides the confidence needed for production. Zone 2 acts as the bridge between them. The benefits of this approach are concrete. AI guardrails prevent data leaks, agent zoning stops governance chaos, and cost controls keep compute sprawl in check. An organization that uses this framework can scale its AI efforts with confidence because they know exactly where their risks are. The organizations that move first to secure this landscape will dominate their markets, while those who wait will simply inherit the chaos. The authorization compiler concept. An authorization compiler is a system that translates high-level business policies into enforceable runtime code, and while that sounds like a dry technical definition, the architectural implications are massive. It represents the fundamental shift between treating governance as a restrictive constraint and treating it as scalable infrastructure. Most enterprises still manage permissions as a series of manual, one-off configurations where a user needs access and an administrator must manually review, decide, and assign that specific right. This process is entirely reactive because it relies on human interpretation every time a permission needs to change or be revoked, which is exactly what happens when you lack a functional authorization compiler. The one-NetEmma approach is different because it treats permissions as compiled infrastructure where you define a policy once at the architectural level using business-meaningful intent. You might state that finance users can access customer financial data they own but cannot export it to consumer cloud services, and the system then compiles that intent into deterministic runtime code. This code is automatically deployed to every access decision point, connector, and app, which allows the policy to enforce itself without requiring a human to make a judgment call for every single request. The performance gap between these two methods is immense, as policy as code frameworks can reduce runtime evaluation time by 50 to 90% compared to old-fashioned interpreted rule engines. A compiled policy executes in mere microseconds because it is certain, whereas an interpreted policy is probabilistic, requiring constant evaluation and exception handling that slows down thousands of decisions every second. This distinction is the core of a stable architecture because a deterministic policy is compiled once and enforced identically across the entire environment. When a finance user tries to access data, the policy compiles to a single unchangeable rule that grants access based on their role and ownership, ensuring the result is the same every time without drift or human error. Probabilistic policy, on the other hand, is interpreted from scratch every time a request arrives, forcing the system to check for exceptions and special cases before making a decision. This logic often leads to different outcomes because an administrator might have tweaked a group membership or added a manual exception since the last check, creating the exact kind of inconsistency where most modern security breaches occur. You should stop thinking of Entra ID as a simple identity provider because calling it that is like describing a major city as nothing more than a single street. In reality, Entra ID functions as a distributed authorization compiler that makes thousands of real-time decisions by compiling policies into conditional access rules, RBAC roles, and data governance constraints. The moment you begin architecting authorization as compiled policy, your entire strategy shifts from managing access to enforcing intent at scale. You stop chasing reactive permission fixes and move toward deterministic enforcement, replacing manual approval bottlenecks with scalable gates that ensure the system actually does what you intended it to do. This shift creates a measurable business impact where new users can be provisioned in minutes rather than days because the policy compiles their roles and flows their permissions automatically. Compliance reviews become trivial because the system simply doesn't permit edge cases to exist, making every single permission traceable to a policy statement and every decision fully auditable. Your breach surface shrinks because an attacker cannot exploit permissions that were never granted, and auditors will find fewer violations because the system enforces compliance by design rather than by accident. Moving from manual configuration to compiled infrastructure is not a subtle change. It requires a complete overhaul of how you view governance. It is the difference between seeing governance as a burden that slows the business down and seeing it as the very infrastructure that allows the business to move faster. That conceptual shift is the foundation for everything that follows. Once you view authorization as compiled policy, you can finally understand the architectural pattern required to scale an enterprise. The control plane versus data plane separation. The specific architectural pattern that allows compiled authorization to scale is the separation of the control plane from the data plane. While this isn't a concept unique to the Power Platform, it is a fundamental principle of systems design that is almost never applied to internal enterprise governance, which is precisely why so many organizations struggle with this function. The control plane is responsible for metadata and administrative decisions, handling high-level questions about what a user is allowed to do and what permissions a specific role requires. These decisions are made infrequently and evaluated with deliberation, meaning they are compiled once and then pushed out to be enforced everywhere across the environment. The data plane is where the actual operational execution happens. managing billions of user interactions, flow invocations, and data transactions every second. When a user opens an app or a flow triggers a connector, those are operational decisions happening at a massive scale that require instant execution without human intervention. Most enterprises fail because they confuse these two layers, treating high-level policy decisions as if they were daily operational tasks. By manually reviewing every permission request as it arrives, they create massive bottlenecks in the control plane and end up slowing down the data plane, resulting in a system that is neither secure nor efficient. In the context of the Power Platform, this usually looks like a user requesting connector access and being blocked by an approval workflow that requires an administrator to manually check the request against policy. This entire sequence is a control plane operation being executed synchronously, which turns your governance architecture into a glorified bottleneck that stops work in its tracks. The proper way to handle this is to define your policy once at the control plane level, such as deciding that all finance users are permitted to use a specific customer database connector. Once that decision is compiled into deterministic code and deployed, the data plane can grant access instantly whenever a finance user needs it, allowing the system to enforce the decision a billion times without ever waiting for a human to click approve again. Cloudflare provides a perfect example of this pattern by using a single control plane object to manage resource metadata like creating or deleting a wiki. While these administrative changes flow through the control plane to update the state, the individual data planes handle the billions of actual user reads and edits, ensuring the control plane never becomes a bottleneck for daily operations. For a Power Platform architect, the control plane consists of your governance framework, the center of excellence, your role definitions, and your conditional access rules. These components define what is allowed by compiling intent into policy code, while the data plane, your apps, flows, and agents, simply executes that policy billions of times per second. When a flow triggers, it shouldn't be waiting for a human. It should be reading the compiled policy to see if it can access a connector and then proceeding or blocking instantly. The human decision was already made the moment the policy was compiled, which allows the enforcement to happen at the speed of the platform, rather than the speed of an administrator's inbox. This separation makes it possible to scale in ways that would otherwise be impossible, as the control plane doesn't care if you have 10 apps or 10,000. New apps and agents simply inherit the existing policy automatically, allowing the data plane to scale infinitely while the control plane remains stable and unchanged. Conflating the control and data planes will always turn your governance into a bottleneck, but separating them turns governance into an accelerator for the entire business. By defining intent once at the control plane and enforcing it everywhere at the data plane, you achieve a level of speed and certainty that manual processes can never match. This architectural foundation is what makes the 1M move work. Once you have deterministic policy and scalable enforcement, you can grow your enterprise users' apps and connectors without ever needing to grow the size of your governance team. The Center of Excellence as value engine. A Center of Excellence is not a governance committee, though that is the comfortable narrative most leadership teams prefer to hear. It is also not a group of people who exist solely to slow down the business or enforce rigid compliance, which is the common fear that keeps departments from engaging. In reality, a Center of Excellence is a value capture engine. It is the specific organizational structure that operationalizes your control plane, acting as the mechanism that converts your high-level architectural intent into a daily organizational reality. Most organizations treat the COE as a cost center or a form of necessary overhead that they simply tolerate because regulators demand some semblance of governance. That perspective represents a fundamental misunderstanding of what this unit is actually designed to accomplish. The million-dollar approach treats the COE as a revenue-generating architecture function, not because it sells a product, but because it unlocks the latent value in your environment while preventing the inevitable value destruction that occurs in a vacuum. The data confirms this distinction quite clearly. Organizations operating with mature centers of excellence achieve 67% faster solution delivery, proving that a well-run COE actually accelerates the business rather than slowing it down. These same organizations report a 72% improvement in their security posture and compliance outcomes, which happens because the COE removes layers of manual approval instead of adding them. The COE compiles the policy once so the organization can execute it a billion times without asking for permission again, making the entire system faster by design. A mature COE operates across 5 specific pillars to maintain this momentum. Strategy and vision defines how the Power Platform aligns with your broader organizational goals, establishing the policies for appropriate use cases and defining what success actually looks like. This pillar creates forward-looking roadmaps that incorporate emerging capabilities like Copilot integration. And because it exists at the control plane level, this is where your policy intent truly lives, Governance and security is where those high-level policies and standards become runtime enforcement through the implementation of specific controls. This is the pillar where DLP rules, conditional access policies, role definitions, and data governance configurations are actually built and deployed. Think of this pillar as the authorization compiler at work, turning abstract security requirements into the hard technical boundaries that protect the enterprise. Enablement and training provides the resources and support necessary to empower makers across the entire organization, effectively converting technical policy into human behavior. If you compile a perfect policy, but nobody understands how to follow it, that policy has failed its primary objective. The COE teaches the enterprise how to operate within these constraints, showing them how to request access, navigate governance gates, and design solutions that fit the established architectural mold. Community building fosters collaboration between makers through shared learning and recognition programs that accelerate innovation while preventing the waste of duplicate efforts. This pillar is your primary defense against entropy through repetition, ensuring that 5 different teams don't spend resources building 5 identical versions of the same solution. By creating mechanisms for reuse like templates and pre-built components, the COE ensures that one solid solution can be leveraged by 5 teams simultaneously. Platform management oversees the technical operations at scale, covering everything from environment management and connector approvals to performance monitoring and cost attribution. This is the operational backbone that keeps the entire control plane functioning smoothly day after day. It handles the infrastructure that the other 4 pillars depend on, ensuring that environments are created correctly, connectors are validated, and every application is properly versioned and tracked. The COE maturity model tracks this journey across 5 distinct levels, starting at the initial level where chaos and isolated innovation are the norms. As an organization moves to the repeatable level, an emerging structure begins to take hold and teams start following basic patterns. The defined level is where policies finally become explicit and documented, providing a clear reference point for every team in the enterprise. At the managed level, the COE becomes a fully operational function where execution is consistent and organizational capability is finally predictable. The final stage is the optimized level where the COE is so deeply embedded in the enterprise that continuous monitoring and improvement happen automatically. At this stage, the enterprise does not just follow the lead of the COE, the enterprise effectively becomes the COE. Organizations that reach this optimized level, what Microsoft refers to as level 500, unlock a much faster time to value and a significantly stronger return on their investment. They benefit from a level of standardization that enables massive reuse. And their innovation accelerates because the underlying chaos has been eliminated. This creates a true alignment between business and IT because the COE acts as the translator between them, making governance both visible and automatic. The financial proof of this model is immense. Organizations with mature COEs frequently report a 30% increase in capacity and a 60% reduction in the need for manual oversight. One specific organization that implemented a formal COE structure managed to recover $400,000 annually just from app rationalization alone. That was only the initial waste elimination, and the value multiplied further as they reduced support overhead, accelerated provisioning, and completely eliminated their audit exceptions. The COE is not a constraint on innovation, but rather the essential infrastructure that makes innovation sustainable over the long term. Without it, you are simply building fast and failing expensively, but with it, you are building with clear intent and scaling with confidence. That is the fundamental distinction between a cost center and a value engine, and it is the difference between simple governance and true architecture. The organization that understands this distinction is ready for the next step. They move toward entropy engineering as a formal architectural discipline, focusing on how to actually measure and manage the disorder that the COE was built to prevent. Entropy engineering as architectural discipline. Entropy engineering is not just a concept borrowed from physics to be used as a metaphor for IT problems. It is a rigorous discipline that treats information theory as an operational reality within the enterprise. The real question for an architect is never whether entropy is happening, but whether you are actively measuring and managing it or simply pretending the disorder does not exist. Entropy engineering applies information theory directly to your systems with the singular goal of minimizing disorder while maximizing overall efficiency. High entropy shows up as uncertainty in your data flows, system interactions, and decision-making processes, while low entropy manifests as predictable and repeatable behavior. You aren't actually aiming for zero entropy, as that is both thermodynamically impossible and organizationally stagnant, but you are aiming for managed entropy within a specific budget. In the context of the Power Platform, this translates to the health of your data and logic. High entropy entities are those complex, tangled webs of interconnected data where a customer record might have been modified by 15 different teams over 5 years. Fields are added for a single workflow and never cleaned up, then repurposed by another team and modified again until the entity is just a mess of historical accidents. A knowledge graph filled with these high entropy nodes will inevitably degrade AI performance because the LLM receives conflicting signals from data it can no longer trust. Low entropy entities, by contrast, are simple, bounded, and purposeful. These are customer records with clearly defined fields, a documented schema, and a clear ownership model that everyone understands. When an AI system retrieves information from a low entropy entity, the signals are clear and the results are predictable. This makes the entire system easier to reason about and far more trustworthy for the end user. In the world of enterprise IT, this entropy compounds across 3 very specific and interconnected dimensions. State entropy refers to data drift, where your Dataverse tables slowly change over time as fields are added or repurposed without any documentation. Nobody cleans up the old fields after a use case dies, so the schema becomes increasingly uncertain and querying it becomes more expensive. The system is forced to navigate through layers of ambiguous data just to find a single source of truth. Interaction entropy involves cascading failures that occur when one system change breaks a chain of dependencies. Flow A calls Flow B, which calls Flow C, and if a single API change breaks Flow B, Flow A might not even realize what happened. It continues to retry and escalate the error, expanding the blast radius until 3 or 4 different systems are impacted. This happens because nobody bounded the interactions or created the necessary circuit breakers to limit the coupling between these services. Architectural entropy is generated by configuration flags and the accumulation of special cases within your policies. A conditional access policy might start with a simple requirement for MFA, but then exceptions are added for contractors, then for the VPN, and then for legacy systems. What was supposed to be a deterministic security model becomes a probabilistic one, where the system can no longer reason about what access will actually be granted because the decision tree has too many branches. These 3 types of entropy do not exist in isolation. They feed into each other and cause the disorder to accelerate. State entropy makes interaction failures more likely, and those interaction failures lead to more architectural exceptions, creating a feedback loop that drifts toward maximum disorder. Without active management, the system eventually becomes so complex that it is impossible to maintain or secure effectively. The architectural solution to this problem is observability, which is fundamentally different from simple monitoring. Monitoring only tells you when something is already broken, but observability tells you why a system is starting to fail before the break actually occurs. An observability platform tracks how many fields a table has, how many dependencies a flow carries, and how many exceptions a policy contains. When these metrics cross a certain threshold, the platform triggers an intervention because the entropy has exceeded its allowed budget. This discipline requires you to set an entropy budget rather than trying to eliminate disorder entirely. For critical paths like payment systems or compliance workflows, that budget must be extremely tight, perhaps allowing only a 5% drift in state entropy or a 3-hop maximum for interactions. These are hard limits, and the moment a configuration crosses them, it triggers a mandatory review or an automated correction. For internal tools or less critical applications, you can afford to let the entropy budget be much looser. You might allow for 20% state drift or a 10 exception limit on policies because the overall risk to the enterprise is lower. Even with this flexibility, the system still has a budget and a threshold that is being actively managed. You are making a conscious decision about how much disorder you are willing to tolerate in exchange for speed. Architectural erosion is the natural state of any system that lacks active entropy management. Every single day that passes without intervention, your configuration drifts, your dependencies multiply, and your exceptions grow. This isn't a sign of a failed implementation. It is simply entropy at work, making the system less predictable and more expensive to change over time. The moment you start measuring entropy, you gain the ability to manage it effectively. Once you can manage it, you can begin to predict exactly when and where things are going to break, allowing you to prevent those failures entirely. That is the core of entropy engineering, and it leads directly to the most important operational question of all. You have to determine which metrics actually matter and how you will use them to drive architectural decisions at the highest levels of governance. Measuring the 1 mm conservative outcome set, we need to move the conversation from architectural theory into financial reality. What does a properly engineered control plane actually deliver in measurable terms? I'm not talking about aspirational goals or marketing slides. These are real, credible, and conservative outcomes observed at enterprise scale. These figures are not promises, but rather the results seen by organizations that actually implemented the frameworks we have been discussing. They are conservative because they do not require perfect execution or masterful change management. They simply require architectural discipline applied consistently over a 6 to 12-month window. Start with app portfolio rationalization. A mature enterprise carrying 8,000 applications can typically reduce that count by 25 to 40% through governance-driven cleanup. You aren't necessarily stopping new apps from being built, but you are finally auditing what exists and decommissioning what no longer delivers value. 4 years ago, someone built an application to solve a specific problem, and while that problem is long gone, the application remains. It still consumes licensing, it still requires maintenance, and it represents a persistent security risk. A properly architected governance framework creates visibility into what exists and who owns it, allowing the organization to decommission ruthlessly. When 40% of the portfolio disappears, the associated risk and overhead vanish with it. Second, consider permission group consolidation. Organizations that have layered security groups on top of each other for years can often reduce that count by 30 to 50% through entitlement lifecycle management. Users accumulate memberships over their entire tenure and almost nobody ever cleans them up. A comprehensive audit identifies the redundant groups, the groups that are never used, and the groups whose original purpose has been entirely forgotten. Consolidation eliminates this redundancy, and a 50% reduction is a perfectly credible target for a cluttered environment. Third, we look at governance support ticket reduction. In most organizations today, 60 to 80% of governance time is wasted on manual reviews, manual app inventories, and manual connector validations. Automation eliminates that manual labor by turning provisioning workflows into self-service and making compliance validation continuous. Support tickets for governance issues usually drop by 20 to 35% because the system is no longer waiting on a human to click a button. Fourth is provisioning acceleration. When a new user joins today, they might wait 3 to 5 days for access approvals. A properly implemented authorization compiler turns policy into provisioning rules so that the moment a user joins, the policy applies and permissions flow within minutes. You can achieve a 25% reduction in cycle time simply by eliminating the approval bottleneck. The policy was already approved at the control plane level, so the data plane executes it without asking for permission again. Fifth, we have licensing cost optimization. Unused applications and orphaned services represent pure waste, often accounting for 10 to 20% of total licensing spend. Intelligent decommissioning is driven by actual usage data, and when you stop paying for what you don't use, that 10% optimization becomes a permanent part of the budget. Finally, there is the reduction in manual governance reviews. 60 to 80% of manual work disappears when you implement true observability. Automated audits replace manual ones, and compliance checks run continuously instead of once a quarter. The organization does not need to be twice as smart about governance because the system is twice as thorough. These 6 outcomes compound rather than existing in isolation. The moment you rationalize your app portfolio, provisioning becomes faster because there are fewer targets to manage. When you consolidate permission groups, audits become simpler because there is less complexity to review. These outcomes multiply each other, creating a massive efficiency gain. The total financial impact is significant. A properly architected control plane routinely unlocks between $750,000 and $2.5 million in measurable efficiency for a Fortune 1000 tenant. This isn't about generating new revenue, but about eliminating waste and multiplying velocity. License rationalization, support cost reduction, and compliance automation are not aspirational goals. They are the observed results of sound architecture. The timeframe is the only catch. This is 6 to 12 months of hard work, not a 30-day quick fix. Serious architectural transformation requires policy definition, framework design, and constant refinement. That work takes time, but the results compound. Organizations that move now will have this conversation with their finance team using hard numbers, while those that wait will simply inherit the entropy. The governance architecture blueprint. Knowing what the money looks like is one thing, but understanding the architecture that produces that outcome is another. This is the blueprint. It consists of 4 layers with clear ownership at each level, and you must execute them in order or you will fail predictably. Layer 1 is policy definition. This is where you state your intent without mentioning specific tools. You should not be asking what a specific feature does, but rather what you are actually trying to protect. You define policies for specific use cases, such as finance accessing customer data or HR accessing employee records. These must be stated clearly and tied to a business purpose. You define your data classification and your risk tolerance, deciding which systems have zero exception policies and which are more flexible. This layer is business-driven and answers the fundamental question of what you intend to do. Layer 2 is authorization compilation. This is the stage where policy intent becomes technical enforcement. You translate those business policies into Entra ID configurations, conditional access rules, and role definitions. You do not ask administrators to interpret the policy, you codify it. If a user is in a finance role and they try to access a customer database, the system requires MFA and logs the action. That is compiled policy. It is deterministic, meaning it executes the same way every single time. You build it here so the data plane can execute it automatically in the next layer. Layer 3 is enforcement and monitoring. This is where your compiled policy meets runtime execution across the Power Platform and Entra ID. You establish audit logging so that every access decision and policy evaluation is recorded. You implement observability platforms and real-time dashboards so the system can watch itself continuously. This layer is security-driven and answers whether the policy is actually executing as you intended. Layer 4 is continuous improvement. This is where you prevent entropy from creeping back into the system. You monitor for drift, such as when someone manually adds an exception to a policy and the system detects it immediately. When a new vulnerability emerges or usage patterns change, you refactor the policy to address the new reality. You cannot assume the policy you wrote in month 3 is still correct in month 12. The world changes and your policy must track with it. This layer is operations driven and answers whether the policy is still correct. Each of these layers has a clear owner. The business owns layer 1 because policy definition is a business conversation about risk and protection. Architecture owns layer 2, as they are the ones who translate that intent into technical enforcement and validate the code. Security owns layer 3, deploying the policies and monitoring for anomalies. Finally, operations owns layer 4, detecting drift and proposing refinements. 4 layers and 4 owners create clear accountability. The critical insight most enterprises miss is that without explicit policy definition in layer 1, you aren't managing governance at all. You are just reacting to chaos and firefighting. When an auditor asks for proof of governance, you won't have a policy to show them. Instead, you'll have a random conditional access rule someone wrote 3 years ago to solve an urgent problem. You'll have a DLP policy full of exceptions and role definitions that nobody remembers creating. That isn't governance. It is just entropy with a label on it. Most organizations skip layer 1 entirely and jump straight to configuring tools. They set up conditional access or assign roles without a clear plan, which means they are working backwards. They are guessing at intent and building enforcement around those guesses. This is exactly how conditional chaos emerges in a tenant. Every exception you add is a sign that a guess was wrong, and every manual override is a policy that failed to account for reality. The blueprint is designed to prevent that failure. You define your intent first, then you compile it, enforce it, monitor it, and refine it. You do not skip steps and you do not guess. This architecture requires a specific organizational model to work, one that separates business intent from technical execution. The next section explains exactly how to staff it. Delegated operations as scaling mechanism. The governance blueprint we just outlined contains a fatal architectural flaw if you attempt to execute it from a single central point. A lone team cannot scale to meet the demands of a modern enterprise, and a central administrator cannot possibly approve every environment, validate every connector, or review every application deployment. In this scenario, the bottleneck is not the policy itself, but rather the human beings tasked with enforcing it. This is why delegated operations is a critical requirement rather than just an optional feature. It serves as the primary scaling mechanism that makes enterprise-level governance a reality. Delegated operations allow central admins to hand off specific tasks to trusted individuals without giving away the keys to the kingdom. A regional IT lead might have the authority to create environments or approve Power Apps deployments in their specific geography, yet they remain unable to modify global DLP policies or delete core Dataverse tables. Because their permissions are granular and scoped strictly to their responsibilities, the central team maintains total visibility and policy control without becoming a roadblock. The traditional administrative model is dangerously binary. You are either a global admin with the power to do anything, or you are a standard user who can do nothing, forcing organizations to choose between two equally poor options. They either grant broad admin rights to regional teams and lose control, or they keep everything centralized and create bottlenecks that eventually paralyze the business. Delegated operations eliminates this false choice by providing a middle ground. Permanent administrative access is a primary source of security debt, but temporal permissions solve this by replacing always-on access with rights that expire. If a contractor needs to manage an environment for a month, you grant them specific permissions for 30 days, and the system automatically revokes those rights once the clock runs out. This design choice removes the need for manual cleanup and ensures that security audits won't uncover orphaned admin accounts months after a project ends. Accountability is baked into the architecture through native audit logging. Every delegated action is recorded, every permission change is tracked, and every deployment remains fully auditable. This isn't about surveillance, but rather about creating a clear trail of responsibility. When a regional lead deploys an application, the system logs the who, what, and when of the change, providing a complete trace if something breaks or if an auditor demands evidence of control. Granular controls finally replace the all-or-nothing permission models of the past. A maker who needs to publish apps in their specific region has no business touching global security policies, so you grant them publishing rights scoped only to their environment. This prevents them from accidentally breaking governance for the entire tenant while still giving them the exact tools they need to do their jobs. This pattern allows governance to scale across massive multi-tenant deployments without creating a single point of failure. A global company with 50 regional offices cannot survive on a single approval queue because that isn't governance. It is death by 1,000 consent requests. By distributing responsibility, each region has a trusted admin who makes local decisions while the central team focuses on setting the global guardrails. The financial impact of this shift is hard to ignore. When regional teams handle their own approvals based on preset policies, the workload on central IT often drops by as much as 50%. A 3-person governance team cannot manually support 500 makers, but that same team can easily manage policy and monitor compliance if they aren't stuck in a request queue. However, there is an uncomfortable architectural reality here. You cannot delegate without absolute accountability. Delegated operations only work when paired with rigorous audit logging to ensure that every decision is traceable. If a regional admin grants a permission that violates a core policy, the central team will see it and escalate it immediately. The system does not rely on blind trust, but instead verifies every actor through continuous observability. Organizations that treat delegation as a scaling tool see environment provisioning happen 3 to 4 times faster than their peers. In a centralized model, a project team might wait days for an environment request to crawl through a queue, delaying the entire project. In a delegated model, that same environment is provisioned in hours because the regional admin approves it locally, allowing the project to move forward while the central team monitors the outcome. Scaling governance effectively requires more than just handing out permissions. It requires a specific set of metrics to determine if policies are being enforced consistently and if regional decisions actually align with central intent. Without these metrics, you have no way of knowing if you are scaling a functional system or simply scaling chaos. Metrics that matter, from IT metrics to business outcomes. Most traditional IT metrics are merely operational indicators rather than actual finish lines. Uptime tells you if a system was available, but it says nothing about whether that system provided any actual value to the company. Ticket volume tracks how many problems were reported, yet it fails to show if those problems were caused by a fundamental lack of governance. These metrics aren't necessarily wrong, but they are incomplete because they describe how the system is running without explaining what it is running toward. To find that answer, we have to look at business-linked metrics like revenue per employee. If your governance framework is working, it should free up capacity for strategic work and drive that revenue number higher. Similarly, if automated provisioning makes the business move faster, your customer acquisition costs should drop as you become more efficient. Whether it's shortening the order-to-cash cycle or increasing the time to market for new features, governance must connect to the things the business actually cares about. Governance-specific metrics serve as the bridge between your architectural choices and these business outcomes. One key indicator is the app portfolio rationalization rate, which tracks how many redundant applications you are decommissioning each month. A healthy framework drives this number up as waste is eliminated, just as a properly managed authorization compiler should drive the number of redundant permission groups down. These metrics do not exist in isolation. They are deeply interlocking parts of a larger system. When you accelerate provisioning through delegated operations, your developers spend less time waiting and more time building, which directly improves revenue per employee. When you consolidate permission groups, your audit exceptions drop because there is less complexity for the auditors to sift through. The metrics validate each other, and if one area stagnates, you can usually bet the others will follow. Executive leadership and IT teams often look at the same system through 2 very different lenses. Executives want to know if the business is moving faster and staying secure, while IT leaders are focused on system stability and resource capacity. Both perspectives are necessary for success, but the dangerous gap between them is exactly where most governance failures live. There is an architectural law that separates mature organizations from chaotic ones. If you cannot quantify a process, you cannot manage it. An organization that doesn't measure its app rationalization rate is essentially building software blindly, and one that doesn't track provisioning speed will always be stuck, reacting to escalations. Without data, you are forced to defend your compliance position with anecdotes and guesses rather than facts. Establishing a routine of monthly governance reviews based on hard data allows for rapid course correction. If you see that permission group consolidation has stalled, you can investigate the root cause, adjust the policy, and measure the results again the following month. The moment you let data guide these decisions, the political friction and opinions that usually stall governance tend to disappear. The difference between organizations that measure outcomes and those that only track technical silos is not subtle. In one company, governance is viewed as a frustrating cost center that slows everyone down, while in the other, it is a value engine that powers the business. Your choice of metrics will ultimately determine which of those two realities your organization inhabits. This leads us to the final architectural challenge of the blueprint. We have the plan and the metrics, but we still need to address the actual implementation at scale. Moving from architectural intent to organizational reality requires a specific structure and a clear roadmap, which is exactly what we will cover in the final phase of this rollout. AI agent governance as strategic imperative. AI agents are not chatbots. That distinction is not a matter of semantics. It is a fundamental architectural reality. When a user asks a chatbot a question, the interaction is synchronous, and the human remains the primary decision maker who chooses whether to act on the response. An agent is something else entirely because it observes conditions, makes independent decisions, and takes actions across your systems while the human is absent. This means the human cannot immediately intervene and often only discovers what happened after the fact, which represents a level of autonomy that changes everything about governance. We have to move from managing access to applications toward managing the autonomy of digital labor. You cannot govern an autonomous agent the same way you govern a standard application that simply does what a user tells it to do. In a traditional app, a user performs an action and the app responds, leaving the human to decide what happens next in the sequence. An agent decides what happens next on its own, and the user is relegated to observing the outcome after the process has already finished. If that agent decides to access sensitive data or escalate a high-level issue, it simply does so within the authority you granted it without asking for approval. This shift in behavior forces 3 new roles to emerge within the enterprise architecture. Reviewers must verify agent outputs by examining what the agent decided to do and validating that the decision was actually correct. They aren't approving the action before it happens, but rather auditing the logic and the results afterward to ensure the agent accurately understood the request. The second role involves monitors who track agent actions in real time to watch for anomalies or unexpected behaviors that don't match the agent's intended scope. Finally, protectors must adjust permissions dynamically, meaning they can restrict an agent that is behaving strangely or isolate one that is currently under attack. These roles are necessary because agents are autonomous actors, and traditional governance models have no way to account for that level of independence. The governance containment gap is the distance between what you can see in your logs and what you can actually control in the moment. Recent data shows that 63% of organizations cannot enforce purpose limitations on their agents, meaning they see the connection but cannot stop the agent from using it in unintended ways. 60% of companies lack a rapid termination capability to kill a rogue process, and 55% cannot isolate these agents from sensitive networks once they start moving. This is not a tool problem that a simple DLP policy or a conditional access rule can fix. It is a structural failure. The reality is that for most organizations, a dedicated agent governance architecture simply does not exist yet. Solving this requires an architectural approach built on 4 specific components. First, Entra-Agent ID provides each agent with a distinct identity so the system can track it separately from standard users or service principals. Second, you must use data boundaries and connector restrictions to compile governance policies for agents just as you would for human employees. These policies are deterministic, defining exactly which data can be accessed and which connectors are strictly off-limits for that specific identity. Third, runtime protection must monitor behavior continuously to fire alerts the moment an agent deviates from its expected operational pattern. Fourth, you need human-in-the-loop triggers that force a person to approve critical decisions or review exceptions, ensuring that autonomy is always bounded by oversight. This is not a separate discipline from Power Platform governance, but rather the necessary evolution of it. The same control plane that manages your applications must now manage your agents, and the same policy framework that enforces intent for users must now do the same for autonomous labor. The center of excellence that oversees your apps is the natural home for agent management, provided they adapt to the fact that agents act while applications merely react. That single difference requires new roles and new monitoring controls to prevent architectural erosion. Organizations that recognize this distinction will build resilient architectures, while those that treat agents like standard apps will inevitably face massive governance failures. The zoned governance model for AI. The moment you accept that agents are autonomous actors, you run into a massive organizational hurdle. You cannot put every single agent into Zone 3 and require full compliance, cost controls, and human oversight for a tool that just summarizes emails. That would turn governance into a prison and kill innovation before it starts, but you also can't let agents run wild in production without any oversight at all. The solution is not a choice between total control and total chaos, but rather a system of zoning that applies different levels of restriction based on risk. By using 3 distinct zones, you can balance the need for enterprise security with the need for business velocity. Zone 1 is dedicated to personal productivity, where an individual user builds an agent to help with drafting documents or organizing a calendar. Because this agent touches no production data and has no access to external connectors, it cannot trigger organizational workflows or modify any critical records. The governance overhead here is minimal, meaning the user can create and run the agent without waiting for a formal architecture review or a compliance audit. If the agent breaks, it breaks in total isolation, and the failure is contained to that single user's environment. This is where innovation lives, because users can experiment at high velocity without being slowed down by corporate bureaucracy. The constraints are not about constant oversight, but about limiting the blast radius so that no risk of data leakage or unauthorized API access exists. Zone 2 covers collaboration, where a team builds an agent to summarize shared documents or route internal requests based on a specific team process. This agent interacts with team-level data and uses pre-approved connectors, which means the organization has already decided which APIs are safe to call. Because this work involves shared information, the team must follow data classification requirements to ensure they don't accidentally expose customer data to the wrong people. Audit logging is mandatory here, so the system records exactly who triggered the agent and what data was accessed during the process. This zone acts as a bridge between innovation and strict governance, allowing for controlled experimentation within a defined environment. Teams have more freedom than they would in a production setting, but the organization maintains visibility that Zone 1 does not provide. Zone 3 is the enterprise-managed tier, where agents handle customer interactions, route support tickets, or make decisions that directly impact the business. This requires maximum governance, including full monitoring, strict compliance enforcement, and constant human oversight for every action the agent takes. Every decision is auditable, and every escalation is reviewable, ensuring that the agent only has specific permissions for specific customers and scoped data fields. If the agent tries to access data outside its narrow scope or use an unapproved connector, the system blocks the attempt and logs the violation immediately. This isn't about providing freedom to the developer, but about providing confidence to the organization that production deployments can scale safely. When customers interact with an agent, they expect their data to be protected. And Zone 3 is the mechanism that enforces that promise. The most important thing to understand is that these zones are not a ladder that every agent has to climb. A personal productivity tool might live its entire life in Zone 1 because it never needs to touch production data, and it would be a waste of resources to move it. Conversely, a customer-facing agent is born in Zone 3 and never goes through an experimental phase in Zone 1 because the risk is too high from day one. The risk profile of the task determines the zone, and the zone then determines the level of governance required. This model stops the false choice between speed and safety, allowing organizations to experiment in Zone 1 while deploying at scale in Zone 3. By setting clear rules and measurable outcomes for each zone, you create a governance framework that actually supports innovation instead of killing it. Data loss prevention as compiled policy. Data loss prevention policies are not security rules, despite the comfortable narrative we've been sold by marketing departments. They are not merely annoying restrictions dreamed up by a paranoid security team to stop people from getting their work done. In architectural terms, DLP policies are compiled authorization decisions designed to prevent specific data flows. That distinction matters because it fundamentally changes how you build them and how you measure their success. Most enterprises treat DLP as a reactive fire extinguisher. An incident occurs where customer data leaks into a consumer cloud service, and the organization scrambles to respond. They write a policy to block that specific connector, deploy it, and assume the problem is solved. Then the next incident happens, they write another policy, then another. After 5 years of this reactive firefighting, the organization ends up with a policy framework so dense and tangled that legitimate work gets caught in the crossfire. Users eventually start bypassing the rules because the system has become an obstacle to their jobs. This isn't governance. It is a high-stakes game of whack-a-mole that blocks good and bad traffic with equal indifference. The one-emet approach treats DLP as a proactive requirement. You do not wait for a leak to happen before you decide how to handle your information. Instead, you classify your data first. Customer financial data is labeled confidential, the employee directory is internal, and marketing materials are public. This classification is not a suggestion or a guess. It is a firm organizational decision. Once that data is classified, your DLP rules should compile automatically from those definitions. Confidential data cannot flow to personal cloud services because the classification makes that restriction inevitable, not because an incident forced your hand. Internal data stays off personal email because the organization decided that was the law of the land. This model stops the bad thing before it ever has a chance to happen. Connector restrictions must vary based on how sensitive the environment is. Development environments require a high degree of flexibility because developers are busy building, testing APIs, and experimenting with new integrations. In these spaces, DLP rules are relaxed, allowing a developer to use a personal cloud service for testing or to export data structures to understand a schema. The constraints here are kept to a minimum. Test environments move toward moderate restrictions where data is masked and real customer identifiers are stripped away. While high-risk connectors are still blocked, reasonable integrations are allowed to function. Production environments represent the maximum level of restriction. Only approved connectors and verified data flows are permitted, and high-risk connectors are cut off entirely. This hierarchy ensures developers aren't tripped up during the build phase while keeping production locked down tight. The difference between reactive and proactive DLP is entirely architectural. Reactive DLP is interpreted rule by rule at runtime, which is a slow and unpredictable process. When a flow tries to access a connector, the system has to evaluate every policy, search for a match, and then decide whether to block it. If your rules are complex or overlap, the results become inconsistent. Proactive DLP is compiled once at the control plane. Your data classification dictates the policy, and that policy compiles into a set of enforcement rules that deploy everywhere. Every application and every flow inherits these rules automatically. When a flow hits a connector, the compiled rules execute instantly without the need for interpretation or searching. The decision is deterministic, leaving no room for ambiguity. A properly compiled DLP framework can cut security violations by 70 to 80% without slowing down the business. This doesn't happen because your users suddenly became more obedient or better at following the handbook. It happens because the policy prevents the violation before the user even attempts it. The connector that would have caused the leak simply isn't available to them, and the data that would have been exposed is inaccessible. By enforcing the policy at the source, you remove the opportunity for forbidden actions. The policy hierarchy follows a clear logic. Organizational DLP defines the global laws. Customer data never flows to personal cloud services everywhere and always. Environment DLP then refines those laws, ensuring production is stricter than development. Finally, application-level DLP goes even deeper. A specific app might be barred from using a specific connector, even if the rest of the organization is allowed to use it. If that application handles sensitive data, that high-risk connector is blocked for that app specifically. These layered policies compile into deterministic enforcement at every single level of the stack. When you treat DLP as compiled policy, it stops being a blocker and starts acting as an accelerator. You get faster approvals because the policy was already vetted centrally rather than being debated for every new request. You deal with fewer exceptions because the rules are deterministic and not open to interpretation. Most importantly, you face lower risk because violations are prevented rather than discovered months after the damage is done. That is the architectural difference between governance that actually works and governance that eventually breaks under its own weight. The next piece of the puzzle that allows this to scale is observability. How do you actually monitor whether your DLP is doing its job? How do you catch it when it starts to fail? You need a way to prove to an auditor and to yourself that the policy is actually stopping what it's supposed to stop. Audit logging and the accountability layer. Unified audit logging is designed to capture everything that happens within the ecosystem. Every time an app is created, a flow is executed, or a permission is changed, that activity is recorded. Data access and agent actions all flow into Microsoft Purview to be filed away. Most enterprises turn these logs on and then never look at them again. They enable logging because a compliance officer told them to, or because they want to check a box for an upcoming audit. The logs sit there accumulating for years, providing perfect evidence of everything that happened without giving the organization any actual understanding of what it means. The one-element approach views logging as a strategic tool for governance rather than a chore for compliance. It is the visibility layer that allows you to optimize the entire system. Audit data isn't just for the auditors, it is for the architects who need to know what is actually happening in the environment. There is often a massive gap between what you think is happening and the reality on the ground, and that gap is exactly where the most important architectural decisions are made. Audit data provides 4 specific capabilities that you can't get anywhere else. The first is anomaly detection. If a user who has never touched a sensitive system suddenly starts poking around in it, the system should fire an alert. This isn't necessarily because they broke a rule, but because they deviated from their normal behavior, and that deviation is worth a look. Second is drift identification. You might have set a policy 6 months ago stating that only finance can touch the customer database, but an audit today shows that accounting and marketing have somehow gained access. Audit data makes that policy drift impossible to hide. The third capability is generating evidence for compliance. When an auditor demands proof that your data protection rules are being enforced, you shouldn't have to guess or scramble. You simply query the logs and show them every attempt to access customer data, along with how the system responded. The evidence is complete, time-stamped, and undeniable. Finally, there is forensic analysis. If a breach does occur, you need to know how the attacker got in, what they touched, and how long they stayed. Audit logs answer those questions step by step and decision by decision. The trail is already there, waiting to be read. Most companies capture these logs and let them sit in a digital basement until they are legally allowed to delete them. They treat the logs as proof that an audit could happen, not as a source of truth for what is actually occurring. Organizations that take a strategic view query these logs continuously. They set up real-time alerts for high-risk activities like bulk permission changes or sensitive data access by an unrecognized user. When an agent starts escalating its own authority, the system detects it and the organization responds immediately. They don't wait for a quarterly review to find out they were compromised 3 months ago. The architectural reality is that Purview gives you the infrastructure, but it's up to you to actually use it. A 90-day retention period might satisfy a basic compliance requirement, but it is nowhere near enough for real governance. The gold standard is 1-year retention with a tiered archival strategy. You keep recent logs hot so they are easy to query and immediately accessible for daily monitoring. Older logs are moved to archival storage where they remain available for long-term trend analysis or deep forensic work without eating up your expensive storage budget. This tiering balances the cost of data with the utility of the information. The financial impact of doing this right is massive. Organizations that maintain full audit logging usually see their investigation times drop by 60 to 80%. When an incident happens, the security team doesn't have to waste weeks interviewing people and guessing at a timeline. They just run a query, and the full story appears in hours. Preparation for an audit becomes much faster too. Instead of spending weeks pulling logs and compiling manual reports, you query the system once and hand over the evidence. It turns a month-long headache into a minor administrative task. The core architectural principle here is simple. Logging creates visibility, and visibility is the only thing that enables optimization. You cannot fix what you cannot see, and you certainly cannot govern what you aren't measuring. Audit logging is the measurement infrastructure that makes the rest of your governance possible. Once you have total visibility into the system, you can see exactly what needs to change and prove that your changes actually worked. This is how you move away from treating governance as a boring compliance checkbox and start using it as a competitive advantage. This brings us to the actual work of making this happen at scale. We've covered the 4 layers of architecture, the COE as a value engine, and how to manage entropy and delegation. We've looked at the metrics that matter, how to compile DLP as policy, and how to use audit logging for visibility. The final step is moving from this architectural understanding to real-world execution. The next section will map out exactly how to put this into practice on a realistic timeline. The 12-month transformation roadmap. This is the operational reality that separates theoretical talk from actual governance. To make this work, you need a realistic timeline with clear phases and measurable deliverables. This is not a sprint, and it certainly isn't a 30-day transformation. We are talking about 12 months of serious architectural work. This process requires patience, discipline, and a real commitment from the entire organization. When companies try to rush this timeline, they just create technical debt that takes years to clean up later. Organizations that follow the full year build a sustainable architecture. And the difference in the final result is massive. Months 1 and 2 focus entirely on assessment and policy definition. You aren't building anything yet because you first need to understand exactly what exists in the environment. You start by auditing the current state to see how many applications are running, who owns them, and what data they can actually touch. You have to map out the current permission structure to find out how many security groups exist and which ones are redundant or orphaned. This is also when you establish baseline metrics for license consumption, support ticket volume, and how long it takes to provision new users. You conduct a governance readiness assessment to see if your current policies are actually documented or even effective. Then you define new policies, but I'm talking about intent, not technical tools. Business leaders have to state their intent for data classification and access control, while architects document those requirements. This phase produces a blueprint of intent that guides every technical decision you make later. Months 3 and 4 are dedicated to authorization architecture. This is where you finally translate that high-level intent into technical enforcement across the platform. You design the Entra ID structure by deciding how users will be organized and what role hierarchy makes the most sense. You design your conditional access policies to determine when MFA is required and which devices or locations the system should trust. This is also when you build DLP rules to define which data classifications exist and which connector combinations are strictly forbidden. You have to define roles for who can create environments, manage applications, or approve new connectors. All of these designs are documented and then validated against the original policies from the first 2 months. If the technical design doesn't actually enforce the stated intent, you go back and revise it until it does. This phase produces your architecture documentation, which is essentially the authorization compiler in its design state. Months 5 through 7 cover the pilot and refinement stage. You implement your designs in a controlled environment like a test tenant with a specific group of test users. You deploy the policies you just built and run real workflows through them to make sure everything works. You need to validate that the conditional access policy actually triggers MFA and that the DLP rules really block forbidden connectors. During this time, you measure the impact on provisioning speed and support ticket volume while collecting telemetry on which policies trigger most often. If a policy is too strict and stops people from doing their jobs, you adjust it based on that data. If a policy is too loose and fails to prevent a security risk, you tighten the requirements. This phase results in a refined architecture that has been tested and proven in the real world. Months 8 through 10 are for the enterprise rollout. You deploy the system across the entire organization, train your administrators, and set up your monitoring and alerting systems. You have to define escalation procedures so users know how to request an exception if a policy blocks legitimate work. You run communication campaigns to explain why this governance matters and show people how to work within the new system. It is vital to provide support channels and actually listen to the feedback coming in from the users. You aren't listening to stop the deployment, but rather to understand how the governance is being experienced on the ground. This phase is what creates true organizational adoption and brings the authorization compiler to life at scale. Months 11 and 12 focus on optimization and scaling. You refine your policies based on production telemetry because the real environment always looks different than the pilot. Real users have different needs, so you adjust the system and implement delegated operations to distribute governance responsibilities. This is the time to measure the actual financial impact of your work. You look at how much money you saved through app rationalization, faster provisioning, and the reduction in support tickets. You also start planning phase 2, which might include AI agent governance or deeper observability. These final months produce the hard evidence of your impact, and this is exactly where that $1 million value finally materializes. The timeline is aggressive because 12 months is not a long time for work this complex, but it is realistic. Organizations that follow this roadmap consistently see between $750,000 and $2.5 million in efficiency gains by the end of the year. Companies that try to compress this schedule usually fail because the architectural debt just piles up too fast. On the other hand, if you extend the timeline indefinitely, the transformation stalls and you never actually finish. 12 months is the right pace to maintain momentum while still building something that will last. The consultant's positioning, from builder to architect. The market is currently commoditizing app builders. Every technology vendor is selling low-code tools now, and every consulting firm has a team that can build basic power apps. Even business users can watch a few tutorials and put together an application on their own. The labor market for builders is flooded, which means the pricing pressure is relentless and you end up competing on speed and cost. The client will eventually find someone cheaper, or they will just hire someone internally to do the work. The profit margin on building apps erodes every single year as the value proposition decays. You are essentially in a race to the bottom against everyone else offering the same basic service. Control plane architects are rare, but it isn't because the technical skills are impossible to learn. It is because the mindset is uncommon in this industry. Most technologists only think about building things like applications, automations, or specific features. Control plane architects think about building the underlying systems that allow those things to be built safely at scale. That is a completely different mental model and leads to a much different value conversation with the client. That is where the real margin lives in this business. Your positioning needs to shift to this. I do not build apps, I engineer the systems that allow apps to exist safely at scale. That one statement changes every single conversation you have with a prospect. When a potential client calls wanting you to build an application, you don't pitch them on faster development. You pitch them on control plane architecture instead. You tell them that before anything is built, you need to understand their governance model and data classification strategy. You ask about their environment strategy and permission architecture, knowing that most enterprises don't actually have one. That lack of a control plane is exactly why their current portfolio is a mess and their security team is always firefighting. Building another app into that chaotic environment just adds to the disorder, so you show them the $1 million opportunity that comes from engineering the control plane first. This conversation attracts a much different type of buyer. You aren't talking to a developer who wants a quick fix for a small problem. You are talking to the CIO who wants to know why their environment is so chaotic, or the financial leader who sees the licensing waste. You are reaching the security leader who is tired of failing audits. These people are the real decision makers and budget holders who want strategic conversations rather than tactical ones. The shift in intellectual property is what makes this move decisive. App builders are essentially selling their labor, where you build an app, the client owns it, and you move on to the next project. The only value there was the hours you were able to bill. Control plane architects sell frameworks and models. You design a governance model, compile it into policy, and then validate the whole system. The client owns the documentation, but your frameworks and policy templates are completely reusable for the next engagement. Your understanding of authorization compilation scales. So every client you work with actually makes the next project faster. You aren't selling your hours anymore. You are selling intellectual capital. The margin structure here is fundamentally different than traditional consulting. An app building project is linear, meaning you bill hours and your costs scale right along with those hours. Your profit is always limited by how many people you can put on a task. A governance architecture engagement is non-linear. Your first project might be expensive because you are designing the framework and proving the patterns. The second engagement is much more profitable because you already have the precedents and templates ready to go. Your costs don't scale with the complexity of the project, but your understanding of the system does. This positioning naturally attracts the right kind of enterprise work. You want to be doing the architectural work that actually matters to a business. This is where the client is desperate for someone who understands the strategy rather than just the tools. In these projects, value is measured in millions of dollars, and the CIO cares more about governance than specific app features. That is the space you want to occupy. You shouldn't be building applications. You should be building the control planes that make those applications possible. The market already recognizes this distinction between builders and architects. Control plane architects can command rates that builders simply can't touch. It isn't because the architect is twice as smart, but because they are solving a much bigger problem. A problem that costs an enterprise millions of dollars if it stays broken is worth a lot more to fix. A client might pay $200 an hour for a builder, but they will happily pay $400 for an architect who understands governance. This isn't just a sales pitch, it is a total repositioning of your value. You aren't being dishonest about your skills, you are just being honest about where the real value lives for the client. You are moving from tactical labor to strategic leverage. The moment you stop calling yourself a builder and start acting like an architect who understands control planes, everything changes. Your pricing, your clients, and your competitive position will all shift in your favor. You are no longer competing on how many hours you can work, but on how well you understand the system. The architecture of seven-figure value. The smartest way to architect $1 million in efficiency is not to build more apps, but to engineer the control systems that prevent those apps from becoming entropy generators. You are not a low-code consultant, you are a value architect. The three scenarios we covered, app sprawl, RBAC entropy, and AI governance chaos, define the problem, while the authorization compiler and zoned governance model define the solution. That seven-figure return is not a magical number because it is the natural result of eliminating architectural erosion across the stack. Your next step is concrete. Assess your current entropy level and define your governance policies before beginning a 12-month transformation. The organizations that move first will dominate their markets, while the organizations that wait will simply inherit the chaos. This is not about tools, this is about systems thinking. And systems thinking is where competitive advantage lives.